In this section, we're going to talk about how you can use the different forms of a quadratic equation or a quadratic function to find the vertex and begin graphing a quadratic. Okay. So first, let's just review really fast what the different forms of quadratic are. We have three forms that we talked about in 7.0, which is standard form, factored form, and vertex form. And each of those forms looks a little bit different, and if you want a refresher on those, pop back and watch the video for 7.0. So we're just going to run through a really fast practice of recognizing what form each quadratic is in and then identifying the key numbers in that form. So remember that when we're in standard form, we're looking for what's your A, B, and C. When we're in factored form, you want to know what A, P, and Q are. And when we're in vertex form, we're looking for what is A, H, and K. So let's look down at this example A. This example is in factored form, and we can tell because we have two sets of parentheses, we don't have any exponents, and so that's going to be in factored form. So your A is the number in front, so that's going to be 2. Your P is whatever number you're subtracting from the first x, so that's a -3. And then your Q is whatever number you're subtracting from the second x, which is 5. All right, let's jump to B. So B is in vertex form, and the way we can tell is because you have a set of parentheses that's squared, and then you're adding or subtracting something at the end. So this is in vertex form. Your A is the number in front of the parentheses, so in this case that number is -1. Your H is whatever number you're subtracting from the x, which in this case is -4. And then your K is whatever number you're adding on to the end. So here I'm adding on a -5 or subtracting. Okay. And then example C is in standard form. And we can tell because there's no parentheses, we don't have any multiplication we need to do, and it's already written out, just 3 terms being added together. So your A is 1, your B is 2, and your C is 4. Okay. So go ahead and press pause and work on filling in these next couple rows of examples to figure out and remember what form each of these are in. Now let's go ahead and talk about why we should even care about the different forms of quadratic. So we have these different forms of equations, and they're each going to help us identify different parts of a graph. So our goal with this unit is that we can sketch the graph of a quadratic equation or quadratic function. So let's just talk about a few important components of a quadratic. So here I have graphed a very basic quadratic, just y equals x squared. Okay. So let's just go through and talk about what each of these words beneath mean. So the vertex is like the bottom. Well, first of all, let's just go through this vocabulary word. Parabola. The parabola is the shape of the graph. So that like U shape, that's called a parabola. So you're going to hear that word a lot used interchangeably whenever we start talking about the graph. Okay. The next thing is the axis of symmetry. So if you look down at this definition down here, the axis of symmetry is a line that cuts the parabola in half. So like if you were to fold the parabola along its axis of symmetry, then the graph would line up perfectly. So in this example up here, my axis of symmetry, well, let me change to a bigger marker, just goes right down the middle. Because if you could envision kind of folding that graph in half along that red dotted line, the graph's gonna match up. So when we talk about axis of symmetry, we're going to write it as an equation that looks like x equals and then whatever number you're sitting at. So in this case, my axis of symmetry is x equals 0 because this dotted line passes through the x coordinate of 0. Okay, so we did axis of symmetry in red on our graph. Okay, let's talk about the vertex. So the vertex is the tip of the parabola. It's kind of like the bottom of the U. Okay. And these parabolas can either be kind of like U-shaped or upside down. So if the parabola opens up, like this one does at the top of the page, then the vertex is the very, very bottom point of the graph. It's also called the minimum point. So you're going to hear that word a lot, minimum point. Okay. And then if the parabola opens down, or the U is kind of upside down, the vertex is going to be the highest point. It's going to be called the maximum point. Okay. In this graph that we have in the top right, the vertex is going to be the ordered pair 0, 0. Okay. The y-intercept is the point where the graph touches the y-axis. Okay, and you always want to write the y-intercept as an ordered pair. And in this case, the y-intercept happens to be the same as the vertex, so we'll just write it as 0, 0. Okay. And one thing that we're going to fill in at the top is that this parabola is opening up. Okay. And you can tell if a parabola is going to open up or down based on the a value. So if you look at any of your equations, any of your forms of equations, they all have an a in them. Whenever a is bigger than 0, the parabola is going to open up. Whenever a is less than 0, whenever a is negative, the parabola is going to open down. So that's one of the easiest things to tell. Is my parabola opening up or is it opening down? Okay. Let's go ahead and talk about how we would find the vertex, axis of symmetry, and y-intercept if you're just given an equation. Okay. So let's talk about finding the vertex first. So if you're in vertex form, as you can imagine, it's fairly easy to find the vertex. So remember, let's just go through each of the letters in this one. Remember, this A in front is going to tell you if the parabola is opening up or down. And then once you've identified H and K, your vertex is just the ordered pair H, K. H is your X value, K is your Y value. Just remember that H is always the opposite of whatever, like if you're adding inside the parentheses, it's going to be a negative H. And if you're subtracting, it's going to be a positive. Okay. All right, so standard form. So again, easy peasy to figure out if it's opening up or down. If A is positive, it opens up. If A is down, it opens. If A is negative, it opens down. The vertex is a little bit more complicated to find. What you do is you figure out what A, B, and C are, and then the x coordinate is this, negative b over 2a. So you take whatever b is, make it negative, and then divide it by 2 times a. And that's just going to be your x coordinate. And then to figure out what your y is, you would just take that x value and plug it back into your equation. And don't worry, we're going to do examples of this. Okay. Now, factored form, remember it looks like a times x minus q, x minus p times x minus q. Factored form makes it really easy for us to find the zeros or the x-intercepts. Okay, and we are going to talk about those even more. But one thing that's important is that your vertex is always going to happen right in the middle of your two x-intercepts. So like say you have a graph and you know that your graph is going to have an x-intercept right there and then again right here. Then your vertex is going to happen right in the middle of those 2 points. So somewhere along that blue dotted line, that's where your vertex is going to be. So that means that when you're trying to find the x value of your vertex, what you're going to do is we're going to take our p and our q, you're going to add them together, those are your two x-intercepts, you're going to divide it by 2. And that's going to tell you exactly where your x-coordinate of your vertex is. So I'll make an x with a little sub v. And then to figure out the y-coordinate of your vertex, you plug x sub v back into your equation. Okay. All right, so a couple things before we move on to some examples. We've talked about finding the vertex. Finding the axis of symmetry is super easy once you have the vertex. It's just x equals whatever the x-coordinate of the vertex is. Okay. The direction of opening is also pretty easy. If A is positive, it opens up. If A is negative, it opens down. And then finding the y-intercept. This is one that is pretty easy, but sometimes people make small mistakes with it. All you do is you plug in 0 for x, and then you simplify. And whatever you get is going to be your y-intercept. Okay? All right, let's go ahead and do some examples. I know that was a lot of information. So let's look at some examples. So if I look at example A, the first thing I'm going to do is figure out what form it's in. And in this case, it's in vertex form. So I'm going to go ahead and find the vertex, axis of symmetry, direction of opening, and the y-intercept. So first identify H and K. So H is 7 and K is 9. which means that my vertex is just 7, 9. Okay. My axis of symmetry comes directly from the vertex. It's just going to be an equation of x equals 7. So whatever the x coordinate of my vertex is. My direction of opening has to do with my a value, so let's just kind of throw in an a right here. Here my a is 1. Okay, so since a is positive, I'm going to be opening up. And then to find my y-intercept, I am going to plug in 0 for all of my x's, and then simplify. So y equals 58. So my y-intercept is 0, 58. That's a pretty big y-intercept. Okay, so whenever you write your y-intercept, make sure you write it as an ordered pair. The first number will always be 0, and the second number is whatever number you get as you work through this process down here. Okay. All right, let's jump to another example. Let's look at B. So with B, we are in standard form. And so let's identify our A and our B. So our A is 3 and our B is negative 12. And we can identify C as well, but to find the vertex, all we need is A and B. Okay. So to find the vertex, remember I have to do negative B over 2A. Okay. So I'm going to take my B value, which is already negative 12. So when I make it negative, it's going to turn into positive 12, over 2 times my A value, which is just 12 over 6, which is equal to 2. Okay. So this is my x value of my vertex. So x value is 2. Now I've got to figure out what the y value is. So I'm just going to come back to my original equation, and I'm going to plug in 2 for all of the x's. So I'm going to get y equals 3 times 4 minus 24 minus 10. So y equals 12 minus 24 minus 10. 12 minus 24 is negative 12. Minus 10 is negative 22. So then negative 22 is the y-coordinate of my vertex. Okay. My axis of symmetry is just x equals the x-coordinate of my vertex, so x equals 2. Direction of opening, so we look at A. A is positive, which means I'm going to open up. And then to find my y-intercept, I am just going to come back to my equation and plug in 0 for all of my x's. Sorry, I'm kind of running out of room. So y equals 0 minus 10. So y is equal to negative 10. Okay. So I'll write it as an ordered pair, 0, negative 10. And that's my y-intercept. Okay. So we are going to jump down and we're going to do an example in factored form, but I want to do one from this last page. So there's a lot more examples you guys can work on. But I want you guys to see what it would look like to actually put these kind of things on a graph. Okay, so in this example J, we're in factored form. We're opening up because A is positive. And for my vertex, I have to take P and Q. So P is 8, Q is negative 3. I have to add those together and divide by 2. Okay, so 5 plus negative 3 is 5 over 2. So that is the x value of my vertex. Then to find my y value, I would plug that in here. And I'm going to simplify this really fast for us, but go ahead and press pause if you need to work it out. So this comes out to be negative 60.5. So it's a pretty big number. And that is the y value of my vertex. So over here on the right, I'm just going to sketch a really rough graph of what this tells me, what the calculations I just did is going to tell me about the graph. So one thing is that I know my vertex. My vertex is 5 halves and then negative 60.5. I should have probably done all those as decimals or all as fractions. So I can now sketch about where the vertex is. It's going to be no over negative 2.5 and then down a lot. And since the graph is opening up, and I know it's going to be a